Right, welcome to lecture 1.7, division of real numbers. So if we think about it, division is the opposite of multiplication. So what I mean by that is if we say 18 divided by 3, we can think of it as 3 times what will give us 18. And if you're not too sure, if you write it off to the side, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, 3 times 6 is 18. So 18 divided by 3 is 6, because 3 times 6 is 18. Another way of looking at it is division is the shorthand of subtraction. So if we take this problem, 18 divided by 3, and we take 18 and we subtract 3, our result is 15. We subtract 3, 12, subtract 3, 9, subtract 3, 6, subtract 3, 3, and subtract 3 again, we get 0. So 3 divides 18 6 times, because it did it 6 times, 1, 2, 3, 4, 5, 6, with nothing remaining. We ended up with a 0 here. We'll talk about division with a remainder later, but right now we're talking about division with no remainders. So here's a rule. We love our rules in math, don't we? So if A and B represent any two real numbers, B cannot be 0. It can be anything else but 0. Then it is always true that A divided by B equals A over B equals A times the reciprocal of B. Now, that kind of might not look like we're multiplying the reciprocal, because isn't B in the denominator? Yeah, well, we're multiplying by the reciprocal. And you'll see it better when we get to division with fractions. So let's take a couple problems and then write it as multiplications. So 6 divided by 2. And that's going to be 6 multiplied by 1/2. 6 divided by negative 2 is 6 times negative 1/2. Negative 6 times divided by 2 is negative 6 times 1/2. And negative 6 divided by negative 2 is negative 6 times negative 1/2. And the results are 3, negative 3, negative 3, and 3. Now keep those in mind. Don't they look pretty familiar? So if you thought about it for a second, you may have noticed that division follows the same sign rules as multiplication. Two positive numbers will result in a positive. Positive 12 divided by positive 6 equals positive 2. One positive, one negative will result in a negative. Positive 12 divided by negative 6 gives you negative 2. One negative, one positive will result in a negative. Negative 12 divided by positive 6 equals negative 2. In the last situation, two negative numbers result in a positive. Negative 12 divided by negative 6 equals positive 2. So now let's talk about division with fractions. And it's easier to think of it as multiplication by a reciprocal. For example, 2/5 divided by 3/4. We can think of it as 2/5 times the reciprocal of 3/4. So remember reciprocal, you just flip the numbers. 4/3. Now it's 2 times 4 is 8. 5 times 3 is 15. So if you didn't follow that, let's do it again. 2/3 divided by 5/7. Nothing to get stressed out about. Let's turn it into multiplication by the reciprocal. So 2/3 times the reciprocal of 5/7 is 7/5. Multiply the tops. 2 times 7 is 14, and 3 times 5 is 15. All right, let's try this again. Negative 3/4 divided by 7/9. Let's do the multiplication by reciprocal. Negative 3/4 times 9/7. So negative 3 times 9 is negative 27. A negative and a positive multiply to a negative. And then positive 4 times positive 7 is 28. Positive 28. Right? I did this problem a couple of ways because you might see it one way versus another way. So 8 divided by negative 4/5. Now 8 is actually 8 over 1. And I want to just put the over 1 there to emphasize, put the emphasis that I do have a denominator. So I'm going to multiply it by the reciprocal, which is negative 5/4. So 8 times 5 is 40. 1 times negative 1 is negative 4. How many times does negative 4 go into 40? Well, number one, they're different signs, so your result's going to have a negative. And 4 goes into 40 10 times, so your result is negative 10. Another way of looking at this is if I go ahead and do the math of 1 times negative 4, I put it under the 8, I can reduce this. How many times does 4 go into 8? 2 times, but they're opposite signs, so it's negative. So my problem reduces to negative 2 times 5 is negative 10. Whether you see reducing at the end point or during the problem, that's up to you. That's totally your preference. All right. Let's take another problem. Negative 4 times 5 divided by 6. So negative 4 times 5 is negative 20. Divided by 6, I'm going to go ahead and reduce now. So 20 is negative 2 times 10. And 6 is 2 times 3. So the 2 can get reduced, and the end result is negative 10/3. Or you might want to reduce beforehand, and I'll let you take a look at that. Last problem for our example is 30 over negative 4 minus 5. Now, if you remember your order of operation, you do division and multiplication before you do adding and subtracting. But here's the problem. You don't have just one number for your denominator, so you're really not dividing by one number, and you can't split it apart. That's not part of the rules. You have to combine the negative 4 and minus 5 together first. So negative 4 minus 5 equals negative 9. Now you can do the division. So I can reduce. So 30 is 3 times 10, and negative 9 is 3 times negative 3, and it reduces down to negative 10/3. Now, even though the denominator had the negative, it's customary not to leave it in the denominator. You can give it to the numerator, you can give it to the whole fraction, but don't leave it in the denominator. It's just, we don't write it like that. All right, here's a few problems I want you to work out on your own. So pause the video, and then when you're done finding your solution, come back and look at my solutions. Now, hopefully you tried these out on your own, and if you do, take a peek at my answers and see if they match to your answers. So let's talk about division with the number 0. Now, I said in the rule that b cannot be 0, but I didn't say anything about a not being able to be 0. So let's take a normal problem of 6 divided by 3 equals 2. Well, in multiplication, 2 times 3 equals 6. Right? So the denominator times the result will give us the numerator. Likewise, let's take a look at when the numerator is 0. 0 divided by 5 is 0. Now remember, the numerator equals the result times the denominator. So 0 times 5 is 0. That's legitimate. Anything times 0 is 0. Here's where we run into the problem. Let's say we don't know what 5 divided by 0 is. I'm just going to call that n. And when we rewrite it in multiplication, the numerator equals the result times the denominator. But what number can I multiply to 0 to get to 5? Nothing, because remember, our rule is anything times 0 is 0, so I can't get to 5. So instead of saying, oops, that's a no-no, we're going to call it undefined. So anytime you run across a denominator being a 0, you can jump to the answer that it's undefined, at least at this level of math. Now when you get to calculus, there's a very special division of 0, and it's 0 over 0. But let's not worry about that until we get to calculus. But until then, this is the end of this video. So until next time, be seeing you.